Hi everyone, and welcome to the third of 4 videos going through some past exam questions on the topic of strong bases and Kw. This first question is one that we've seen before in a previous video. It's asking us whether the dissociation of water is exothermic or endothermic. So if we use the data that they've given us, we can say at higher temperatures Kw, what's happening at the higher temperature, Kw is a bigger value. So if Kw is increased, this means the equilibrium must have shifted to the right. When the temperature increases, the equilibrium shifts in the endothermic direction, doesn't it, to decrease the temperature again. So therefore, when you increase the temperature, the equilibrium would shift in the endothermic direction. It has shifted to the right, so therefore to the right is the endothermic direction. So therefore, dissociation of water is endothermic. Okay, second bit here. Predict, using a calculation, whether a pH of 7 at 60 degrees is neutral, acidic, or alkaline. Now, this might seem like a strange question. You go, well, pH 7 is going to be neutral, but that's only true at 25 degrees, because at 60 degrees, Kw has got a different value. Okay, so we are going to have to actually work this out. So to work out whether it's neutral, acidic, or alkaline, we need to compare the H plus and the OH minus concentrations. If it's neutral, the H plus concentration and the OH minus concentration will be equal. If it's acidic, the H plus concentration will be higher. If it's alkaline, the OH minus concentration will be higher. Okay. Well, the first thing we can do is, if it's pH 7, then the H plus concentration is going to be 10 to the minus 7. Okay. So then we're going to work out the OH minus concentration. So we'll use Kw. And if we want to work out the OH minus concentration, then the OH minus concentration is going to be Kw divided by the H plus concentration. Okay, which means that the OH minus concentration is going to be, we're at 60 degrees, so we're going to have to use this value of Kw, 9.311 times 10 to the minus 14, divided by the H plus concentration, which we know is 10 to the minus 7. So that's going to come out as, well, if we're just dividing by 10 to the minus 7, we're going to get 9.311 times 10 to the minus 7. So therefore, the OH minus concentration is bigger than the H plus concentration. So therefore, the solution is alkaline. Okay, here we have something, we've got pKw. We've not seen this before, but you can see they're trying to link it to things you've had already. pKw, pKa, pH, they're all logarithmic scales. Anything with a little p in front of it means we're doing the negative log. Okay, so pKw is going to be the negative log of the Kw value at 60 degrees. So we're going back to this value that we have here. Okay. So it's negative log of 9.311 times 10 to the minus 14. Okay. So then we can just work that out. And 2 decimal places, so 13.03. Okay. Right, this question carries on. So it then says, we have this sodium hydroxide solution, it's diluted with water, calculate the pH of the diluted solution at 60 degrees. Okay, well, we're going to start with writing out Kw. And if we want to calculate the pH, we're going to want the H+ concentration. So it's going to be Kw divided by the OH- concentration. It's at 60 degrees, so we're going to use the other value of Kw. We'll go back to that in a minute. But then we need to work out the OH- concentration. So that's where we're going to do this. So again, I'm going to do this the long way round. You can see that we've gone from 20 centimeters cubed to 100. So the volume has been times by 5. So the concentration is just going to be divided by 5. But let's do this the long way round in case it wasn't nice numbers. So we'll do 20 over 1,000 decimeters cubed times by the concentration to get the moles. Okay, this method works every time. There's nothing wrong with going that the volume's times by 5, the concentration is divided by 5. Just do that. Yeah, if you can see that, just do that. It's much quicker. But it won't always be nice numbers. So this method will always work. So we've got 5.4 times 10 to the minus 4 moles of NaOH. And then we want to do the moles divided by the new volume, which is 100 centimeters cubed. Which is going to be 5.4 times 10 to the minus 3. So then the H+ concentration is going to be the value of Kw. So if we go back over the page, it was at 60 degrees, wasn't it? So we're going to use this value of Kw here because that was the one from 60 degrees. So it's 9.311 times 10 to the minus 14. And we're going to divide that by the concentration that we just worked out. So 9.311 times 10 to the minus 14 divided by 5.4 times 10 to the minus 3. 1.72 times 10 to the minus 11. So therefore the pH is the negative log of that value. And it wants 2 decimal places again, so it's 10.76. That's a sensible value for the pH of sodium hydroxide, isn't it? Yeah, we're expecting it to be alkaline, so that seems reasonable.